So in this chapter, the main result is we're going to show that a vector space decomposes into a direct sum of generalized eigenspaces, and on each of these is going to be invariant under T, and in fact T is going to act nilpotently on each one of these guys. So as a warm-up for this, we're going to need a little lemma, and the lemma is about the invariance of the null space and range of T. Now, we actually proved that the range and null space of T are invariant back in 5.3, so that's where we did the case where we were looking at the identity polynomial. So now we're going to extend it to a general polynomial. So if P is any polynomial, we're going to prove that the null space of P of T and the range of P of T are both invariant under T. And so this, the trick for doing this is going to be using the result from 520, which is that polynomials in T commute with each other. So you can write them in whichever order you like. Okay, so let's do it for real. So we want to show first that the null space is invariant. So suppose V is an element of the null space of P of T for some polynomial. Then to show invariance, we need to see that when we apply T to this thing in the null space, it ends up back in the null space. That's the meaning of invariance. So let's see. So we're going to apply PT to the output and see that it's still in the null space of PT. So in other words, we want this expression to equal 0. So let's see. So the first thing that we can do is we use we can exchange T and PT by 520, as I just pointed out in purple there. And now V was chosen to be something from the null space. So that means that this part here evaluates to 0. So we have T of 0. And then any linear map always takes 0 to 0. So this gives us 0. So what does that tell us? So we can conclude that TV is in the null space of PT. So if we start in the null space PT, we end in the null space of PT after applying T. Cool. All right. So now we just need to check the range. And it's basically the same kind of argument. So suppose V is in the range of PT. All right. Well, then that means that there's some U that gets mapped to it. Oh, whoops. Mapped to it by PT. Okay. So if we now apply T to V, then that's applying T to PTU. But again, we can interchange them by 520. So that's PTTU. But then we have, well, what's that coming out? So TV, actually, I don't need that equality there. What this says is this says that TV looks like PT applied to something, right? So that means that it's in the range. And we are done.